You might have wondered whether organically grown vegetables are healthier than less expensive store-bought vegetables, or if cell phone use causes car accidents, or if students who take online statistics classes are more successful than those who take it in a traditional classroom. In order to determine the answers to these questions, we want to collect data. Data consists of observations or events. We collect data from the largest group we're studying, called the population. And then, from there, we choose a smaller subset of the population called the sample. Since most of the time the population is large, it's very difficult to get the entire population. For example, if I want to study the success rates of online students in statistics, it would be impossible to reach every online statistics student. However, if I reach a smaller representative set called the sample that is collected without bias and represents the diversity of the population, that is optimal. The observations or data may be either qualitative or quantitative. For example, if I'm studying online students, I might want to know whether there are more males or more females. Or possibly I want to know about the GPAs of all the students who take online classes versus traditional classes. Qualitative data is a categorical measurement, expressed in words or descriptions. These measurements are observed. You can remember this term by thinking of the word quality. Like, what quality does this represent? There are entire courses on qualitative research that focus on surveys, categorizing, and describing the world around us. Examples of qualitative data include gender, race, and religion. We call this information nominal level data. Sometimes qualitative or categorical data may be ordered, like t-shirt sizes, small, medium, and large, or sales production, high, medium, or low. We call this ordinal level data. Quantitative data represents a quantity or amount. This data is numerical. Sometimes it's measured by, like, air quality, or number of car accidents resulting from cell phone use, or graduation rates at a particular college. Quantitative data that is measured but does not have a true zero, like temperature, is called interval data. The reason why temperature is in Celsius or Fahrenheit scales do not have a true zero is because 0 degrees does not mean there are no degrees. 0 in this case is a value that allows us to compare other temperatures. Another type of quantitative data is ratio level data, like measurements of GPA, blood pressure, yearly corporate profits, or electrical charge. Let's review the levels of measurement. Stanley Smith Stevens, a psychologist, first proposed the idea of levels of measurement in 1946. Stanley Smith Stevens suggested that there are 4 levels of data when we do research studies or experiments, and these are nominal, ordinal, interval, and ratio. Nominal level data, like eye color, has no order, only a category. I remember it by saying the nominal data is in name only. Thus, it is just a name, like types of cars or colors of jelly beans. Ordinal level data is similar to nominal data because it's categorical, but this data can be ordered, like surveys you complete with a Likert scale. Let's say the question says, is your online statistics class interesting? Well, I would hope you rank the question strongly agree. A Likert scale, named after psychologist Rensis Likert, is a rating scale that is commonly used in surveys and questionnaires. Interval data is quantitative or numerical data, but the 0 is arbitrary because it does not mean there is no value, but 0 is only used for comparison. An example of interval data is longitude and latitude. Although the longitude and latitude can be ordered, there is no true 0 where the Earth starts, except for the arbitrarily defined location of geographic coordinates. Finally, we have ratio data, the highest level of measurement, which has a true 0, like the number of baskets made during a basketball game or the height of the tallest basketball player. In ratio level measurement, saying something is twice another value has real meaning, like the score at the end of the game was twice the score at halftime. You can try this with interval level data, and this will not work. For example, if it's 20 degrees rather than 10 degrees, are you twice as cold? When we do a study, we want our results to be accurate within some small margin of error. We want our results to reflect the individuals that are in our study. Studies that are unbiased, with sample elements that are randomly assigned, have a greater assurance that the study can be replicated with similar results. We can do observational studies or experiments, In an observational study, the researcher observes the outcome and draws conclusions based upon these observations, while in an experimental study, the researcher applies a treatment to the experimental units and observes the effects of the treatments. Many times in an experimental study, there is a treatment group and a control group. Let's say the study is determining the impact of running on short-term health. The treatment group is asked to run each day, while the control group might be told not to exercise for the given period. Since there are ethical considerations that must be met and review boards monitor studies so that they do not violate these rules, many studies are observational. There's a saying that says, garbage in, garbage out. Our goal in statistics is to carefully define the study, collect unbiased information, organize the data, and carefully consider where and how the generalizations may be used. Voluntary response or convenience sampling is often not reliable. In this type of sampling, the respondents are self-selected or chosen because they are within close proximity and easy to obtain. When people have strong opinions about an issue or concern, they're more likely to volunteer for the study. Often, the only responders to a volunteer survey are those who represent the extremes because they're the only ones who care enough to answer. Examples include abortion, gun control, prayer in schools, and gay rights. These issues are highly charged, and respondents often do not represent the diversity of the population. Whether you're doing an observational study or an experiment, you want to randomly select all elements being studied. In an experiment, it is important to randomly assign members to both the treatment and the control groups. We can do this random assignment by giving each participant a number and then use random numbers for the selection. In order to consider how this would work, you first want to ask if you have carefully defined the population you're considering and if you have a master list of the individuals in the population. If yes, then you might choose a simple random sample or a systematic sample. In the simple random sample, members of the population are selected in such a way that each individual member of the population has an equal chance of being selected. In a systematic sample, a starting point is selected and then every nth element of the population is chosen. For example, if I have a list of all the members of a company with 1,000 employees, I might sample every 20th member from an arbitrary starting point so that I observe 50 employees for my study. If there's no master list, then you might want to determine if there are clusters like counties, states, or business sites, or levels like socioeconomic classes. Then select random clusters or strata from the population. It is easy to confuse stratified sampling and cluster samples. The main difference is that in a stratified sample, all members of the population may be chosen because the random assignment comes from this entire strata, whereas for cluster sampling, only those members of the selected cluster may be chosen. For example, if I wanted to study voter preferences in California and I used stratified sample by socioeconomic class, then if I randomly chose 100 voters from each of 5 income levels, then every single voter could possibly be selected. However, if I chose a cluster sample by county and I selected 100 individuals from each of 5 randomly selected counties of the 58 counties in California, then only the voters from those 5 counties would be considered. This image gives you a visual of the types of sampling and a clear way to consider the sampling choices you might make. When you do your statistical study, either observational or experimental, make sure that the members are selected at random and that you work hard to minimize any bias. Statistics is the collection, organization, and analysis of data. In this video, we only talked about levels of measurement and methods of sampling. In future videos, we will talk about the organization and analysis of data.